Kia ora, Year 12 and Year 11. This is the second video for class tomorrow, and this goes over how to find the perpendicular distance of a point from a line. So this again uses the idea of the dot product or scalar product, but you have to go quite carefully with these questions. So what I'm going to do is the example that comes before exercise 10D, and I'm going to go pretty slowly. So some of you may want to just work through this in the book yourselves. Just make sure that you've really got it down if you do choose to do that. Okay, so suppose that we've got a point, and the point is going to be labelled P, right? So P is 11, -5, and -3. And then we've got a line, right? And the line is given to us in the following form. So we've got the vector equation of a line. So that's my starting point. And then my direction vector is -3, 1, 4. So let's now draw the point and the line, right? So we've just got a random line here, that's line L, and we've got a point P here. When you're doing questions like this, always draw a diagram. So what we're trying to find is where on this line, and we're going to call it point N, is the distance from P the shortest. And what is that distance? Okay, so is N going to be out here? Well, obviously it's not, right? So you're pretty familiar with this idea. N's not going to be here. It's not going to be here. And it's not going to be here. But it is going to be, let me change pen color, right here, right? So the defining feature of the point on that line, which minimizes the distance from the line to point P, is that this is going to form a right angle. And that makes this problem very doable, because we know the following fact, that if I take this vector here and this vector here, their dot product will equal 0. So basically what it comes down to is this. I'm going to find an expression for this vector, and I've already got an expression for the direction vector for this line, right? It comes from here. And I'm going to find the dot product of those two things. I'm going to set it equal to 0 and figure out the value of this parameter. And that's going to generate me point N. First of all as position vector N, and then I'm going to turn it into point N. Lastly, I'm going to find this distance by using Pythagoras. Okay, so let's get going. There are a couple of little fishhooks in here, right? So let's think about all of the points on line L, right? So a point on line L is given by what? Well, it comes out of the equation of the line. So the position vector for a point on line L is this: 1 minus 3 lambda, 5 plus lambda, and 4 lambda. Right? And so at point N, we're going to pick a value of lambda. So we're going to say let lambda equal t. So just give it another variable name. And we want to have, so at this point, what do I want? Well, from P to N, I want that to be perpendicular to L. So I need to figure out what is this vector of going from P to N. Right now I can either do it as going from P to N, or I can do it as going from N to P. Right? Because I'm trying to solve for when they're perpendicular. So I'm solving something equals 0. So in the earlier examples we were quite careful to say that if I'm starting with this as my vertex, I want to have, I'm trying to clean this up a bit, let's get rid of some of these markings. Right? So we've got our line here. Right, so put up with this because this is kind of important. Because before, when we did the last example about finding the angle between two things, I said we're always going to start at N, and we're going to be very careful to go out from N to P, and then out from N this way. Right? But that actually is a little bit fiddly. And so here, because I'm solving this dot this equals 0, it doesn't matter which way around I go. So what I'm going to do is I'm going to find from N to P, and then I'm going to use the direction vector of the line. and I'm going to get the dot product equal to 0. So from n to p, it goes like this. So np means I'm going to write this out from n to p. So what's the vector of p? Well, that comes from OP minus ON. So OP is 11, negative 5, negative 3. That's my point turned into a position vector. Minus 1 minus 3t, 5 plus t, 4t. So that works out to be 10 plus 3t, negative 10 minus t, negative 3 minus 4t. And that's actually most of the hard work done. Right, so that gets me from point N, which is this one here on the line, right, out to point P. Okay, so first bit done. So we're now trying to find T such that this 10 plus 3t, negative 10 minus t, and negative 3 minus 4t dot negative 3, 1, 4 equals 0. And it's pretty easy to go from here, right? So working through that algebra carefully gives me this. I've got negative 3 times 10 plus 3t plus 1 times this plus 4 times negative 3 minus 4t, and that equals 0. Now cleaning that up gets me this, which simplifies to negative 52 minus 26t equals 0. So that gives me t equals negative 2. So how does that help? Well, now if I look at my line, I know that this point N is the point where t equals negative 2. And when t equals negative 2, this is perpendicular. So I'm going to substitute t equals negative 2 back in to get n. So ON is 1 minus 3t, so it's 3 times negative 2, 5 plus t, so 5 plus negative 2, and 4 times negative 2. And that gives me 7, 3, and negative 8. So my point is going to be n, 7, 3, negative 8. Now, what about NP? Well, it's the same idea. I go up to here, and this is NP. So I'm going to substitute in t is negative 2 into here, here, and here. So NP is equal to 10 plus 3 times negative 2, negative 10 minus negative 2, and negative 3 minus 4 times negative 2. And that gives me this vector. So this is the vector that gets me from N to P. So if I want to go back and look again at that diagram, I have to find the length of this line. So I find the magnitude of vector NP. Which is 16 plus 64 plus 25, which gives me the square root of 105. Okay, or 10.25 units. Right, thanks for watching. All of 10D uses this idea, right? So lots and lots of practice at how to do that. In some of them you'll have to figure out the direction vector. And then questions 4 and 5 in there are nicer ones that are taken from old exam papers. So make sure you get through those. The helicopter question is especially good to do. If anyone knows how I can turn off the cursor when I'm working with OneNote, I would really, really appreciate you telling me how to do that tomorrow or the next day. Thanks for watching.